in Unit 2, we talked about solving systems of equations, and we did a class graph. So when we look at our solving methods, we looked at 2 today. There will be 3 total. The first one we did today was graphing. I'm going to make a sketch. When we graph, we are looking for a point of intersection. So that was the first method, graphing. That method is easier when both equations are in y equals mx plus b form, and it's easy numbers to graph. You wouldn't do that with decimals or large numbers. The second method we did was substitution. And I've got some steps for us to follow. When do we do substitution? Yeah, when we have y equals something. So maybe you can solve one equation for y. So it's y equals something. Then you'll plug it into the other equation. Once you know one of the variables, you'll plug in your solution. And solve. So in the end, you should have an x and a y. You should have 2 answers here. We'll do an example of this in number 3 in the check. These are just the steps that I outlined. Substitution. We're going to do a form of substitution. They told us the x and the y, like the answer. So I'm going to take my y and replace it with -2. I'm going to take my x and replace it with 3. And I'm going to see if it works. So I'm going to check it. This is a check. So this is a check. We know the answer. We're checking it in the system. We get -2 plus 12. Oh my gosh, we get 10 equals 10. So does that mean it works for the whole system? What should we do next? What do you think, Kia? What should we do next? Check the other one. Yeah, let's check the other one. So I'm going to replace x with 3. And be careful here, when I substitute a negative in, I need parentheses, so I'm subtracting a negative. That's going to turn positive. So now I've got 15 plus 2. Uh-oh. Does 17 equal 13? No. This is a big no. This does not work in this system. It is not a solution. It has to be true for both equations. It was true for the first one. It wasn't true for the second one. Questions? Let's do the graph together. Some of you already started the graph. Let's do the graph. I noticed yesterday on your test, some of us are still doing slope wrong. Uh-oh. I'm going to color code. I'm going to do the first one in green. I'm going to do the second one in red. Here we go. How do I graph the first one? Where do I start my graph? Where do I start it?
4.
At 4 on the y-axis. And how do I move?
3 to the right, like 1.
Ooh. No, what?
Down 3 over there.
It would go up 3 and right 1. Oh no, we go off the graph. That's okay. We can go the other way. We can go down 3. 1, 2, 3, left 1, and we land right here. If you've got a ruler, you can connect those points. Okay. Where does the second one start? At -1. And how does it move? How does it move? Down 2 and over 1. Down 2, over 1. Down 2, over 1. If I work that backwards, you should see the point of intersection on our graph. Where's our point of intersection? What's the point? -1, 1. Questions about graphing? Some of us still need to work on slope. Number 3, we're going to do substitution. How should we start it? Which equation should we start with? The first one or the second one? The first one, and what should we do, Noah?
Subtract 7 from both sides.
Yeah, let's subtract 7 from both sides. And now I got y equals 4x minus 7. What do I do with that now? What do I do with that? How does that help me? I'm going to take the second equation, and instead of writing y, what am I going to write? Yes, 4x minus 7 is going to replace that y. And you should notice now I have an equation with all x's. I want you to solve for x right now with your team. You can solve that. Don't forget to distribute to both terms. And you will get a decimal. That's okay. When you're ready, you can check. Am I done after I find x? Nope. Go back and solve for y. So finish it. Solve for y. Try to solve for y now. Plug it back into one of the original equations. Plug it back into an original equation.